Okay, today I want to talk to you about the research hypothesis. I know that you've been reading about different types of hypotheses in the textbook, and the textbook talks about hypotheses that are directional and hypotheses that we base our research on, and hypotheses that are even this strange word null. And so you've seen these. Let me write this up here. And those words that may not make much sense to you in things that you've looked at before, but the null hypothesis, I wanted to talk to you especially about that one. Most of the time in research, whenever we're dealing with hypotheses, it's either a directional hypothesis or a null hypothesis, because in a directional hypothesis, it's really a prediction. And so in this prediction, you are hypothesizing how things will turn out in the study. And so, for example, if you have a corn study that you predict that a particular application of a herbicide or a pesticide is going to increase production, then you're going to state that in your hypothesis that this application of a specific herbicide to the crop, distributed over top of the crop or side dressed or however you're going to do it, may increase production in your crop. And so this is a predictive hypothesis. But for the sake of statistical analysis, you also develop a null hypothesis. And so this null hypothesis is a little bit strange to state because it's always stated in the negative. It's always stated that something will not have a statistically significant effect. And so we're going to talk in another video about different types of variables. You've been reading about those types of variables. But we want to look at this null hypothesis as no difference. And so, for example, in my corn example, your null hypothesis, even though your prediction might be that the application of this pesticide at a certain time in growth might increase the production in your corn crop, your null hypothesis is actually going to say really the opposite. The null hypothesis is going to say that there will be no difference. And so you may have a control group, or you certainly will have a control group, and an experimental group. And in this control group and experimental group, you're going to use one to compare the other two. The control group, of course, will have will not have the treatment that you're testing, and then the experimental group will have the testing, the treatment, as I mentioned before, could be the herbicide application or whatever, but it's going to be in the experimental group. And so your null now is no difference. No difference between the experimental and the control. And what that does is set you up for your statistical analysis. And I know that sounds kind of strange, okay? We've got a research prediction that says that increased production will come from this experimental treatment, but then we've got this null hypothesis that says there'll be no difference between the experimental and the control group. And that sounds kind of strange, but it sets you up for your statistical analysis. And so what happens is you get your data from your control group, and you're probably going to look at a mean growth in the control group and a mean growth in the experimental group. And so if you're looking at this, a control versus the mean of the experimental, the result that you're looking for is statistical significance. And so if you predict that there will be no statistical significance between the two with the null hypothesis, and then you do, in fact, find statistical significance, it's a mouthful, then you can reject the null hypothesis and move forward with greater levels of testing. And so that's really the first step to determine whether there is a difference between the two. If there's no difference between the two, then there's no need in researching this any further. And so a predictive or a directional hypothesis will predict how this thing is going to come out, but the null hypothesis, which is only used for inferential statistics. And we'll talk more in depth on a future video on types of statistics. But inferential statistics is where you use one small group to infer to a larger group. And so you take a sample, and you use that as a growth experiment or with people or whatever you're doing. You take a sample and then you base those results and generalize it to a larger population. And so that's when you look at this null hypothesis. You would not use a null hypothesis for something that would be just a descriptive in nature. And so if we're looking at the characteristics of, I don't know, let's say of very successful agriculturalists in whatever field, and you're looking at descriptive characteristics, there's no call for a null hypothesis. Now, if you're looking at descriptives of a very successful agriculturalists versus those that weren't very successful, and you're going to take some measurement of both and compare them to and see if their attitudes or maybe their practices, which we would hope that they're different, to see if they differ, then you would set it up as a null hypothesis. But if it's just something that you're looking at a description with descriptive statistics, you certainly will not have a null hypothesis. And so many of you will have research questions. Those of you who use statistical analysis in inferential statistics will have a null hypothesis. You don't have to have a predictive or a directional hypothesis. Sometimes those go even unstated, but they're not necessary to have. And so you use these nulls to compare the control and the experimental group. Hypotheses are sometimes kind of confusing whenever you first come across them in this context, but it won't take you long before you're really able to hammer out the differences between the null and the research or the predictive or the directional hypotheses. So once again, keep up the good work. I enjoy the questions and the interaction and the discussion about these topics. Thanks a lot.